Hello and welcome back. In this section, we are going to discuss DynamoDB's read consistency models. DynamoDB gives you a high durability and availability environment, and it achieves this by using read replicas, which are nothing but multiple physical nodes spread across different regions. Now, although we successfully avoid some setbacks and failures by this approach by replicating data across different physical nodes spread across regions, but it also causes some problems. Now, because we are spreading our data across different regions, it takes up some time to propagate the changes. For example, when you write a data or when you update the data, it will obviously take some time for your data changes or new versions to propagate to different regions. And this results in inconsistencies when you try to read the data back after you have recently made a change to the data. Read consistency becomes really important in scenarios where the amount of time it takes to reflect changes in data is important. For example, when you're doing a bank transfer or other financial internet transactions, it becomes really important for the changes to reflect real fast. Or for example, you have stock market where there are billions of transactions happening, and it becomes really important for data to reflect real fast with the latest version. Now, DynamoDB provides two read consistencies. The first one is eventually consistent reads, and the second one is strongly consistent reads. When DynamoDB table supports eventual consistency reading, the response will not reflect the results of a recently completed mutation. And your result of a query may include some stale data, which is nothing but an older version of your data. It may take few milliseconds or seconds to propagate your data changes across all the read replicas. Now, another mode is strong consistency. So when you enable strong consistency while making any of the read operations to your DynamoDB table, like get item, or when you're querying or scanning, DynamoDB makes sure that the latest version of the data is sent back. So in the background, it makes sure that any recently changes to data via create or update queries have been replicated across all the read replicas across regions. Now, of course, there are some pros and cons of opting for one of these consistency model. For example, when you're using eventual consistency model, DynamoDB always returns data with lowest latency possible, but of course you may get stale data. But if you choose strong consistency, DynamoDB guarantees that you get the latest updated data, but with higher latency. Also, if there is a network delay or outage and you're using strong consistency read mode, you might not even get any data. Another important thing to note here is if you are using global secondary indexes to query data from your table, strongly consistent reads are not supported. So only LSIs or local secondary indexes support strongly consistent reads. And of course, because DynamoDB is doing greater amount of work in the background, if you choose strongly consistent reads, it's using extra resources to make sure that you get the latest version. Thus, it uses more throughput capacity than eventually consistent reads. Now, eventually consistent read is a default mode in DynamoDB. So if you want to use strongly consistent read, you have to explicitly set consistent read attribute in your queries to true. So for example, if you're querying your orders table here with key as order ID, this is your primary key, and user ID can be your sort key. And if you want strongly consistent reads from your strongly consistent read from your table, you need to send consistent read as true. Also, this is a very basic example of how you can make read queries on your table using AWS SDK. We will see it in more details as we progress in our lectures.